Yeah.
Thank you very much. This is a workshop about writing scripts in PixInsight. It's a workshop that will introduce the topic. Of course, we don't have the time to cover too much, let's say, as a first introduction, but we will cover the most important things that I think anyone should be aware when approaching the scripting in PixInsight. The idea has come from the administrator of PixInsight Italia, Edoardo, and me. We were thinking about creating something to engage the people to something new. We don't have many materials, let's say, talking about scripting, neither written nor in video. So we decided to do it as a kind of new stuff to talk about. I would like to share some slides I've prepared, but in general, let's say I didn't thought about this workshop to follow some slides. I thought it to be a kind of a live coding session where I will present you an idea of a simple script that we can build in 1 hour, 1 hour and a half, whatever it will take. And that will be a simple script, but it will contain all the elements to be fully integrated in PixInsight, instantiable on the workspace, installable in the menu, and in principle also submittable to the community, right? So something simple, but that will cover the main topics that I think is good to know at the very beginning. Okay. So the topic that we'll talk about are the following. So first of all, I will give some introduction about me and why I chose to do this workshop. Then I will talk a bit about the environment for developers that PixInsight offers as a built-in tools to develop. We'll start then to this live coding session where we'll write our first hello world script. Super simple, but this will help us to start orientating through the tools and orientating also to understand how to gather information regarding how to do things, right? How to know what kind of object we can use in our language and how to inspect the properties, how to inspect the functions that we can use and how to use them. Then we'll talk about an important thing, a fundamental one, I would say, which is the execution context of scripts. And then we'll see how we can execute processes by scripting them and integrating them in our script. The next, so once we'll be able to, let's say, manage the context, the execution context, and we learned how to execute processes on images in the script, we will talk about how to design a user interface that will let the user to input some parameters in order to get these parameters, customize our process and apply it to the image. And then the final step will be to add another feature to our interface in order to be able to drag the standard, let's say, blue small triangle icon on the workspace or on an image in order to create a script instance on the workspace or to execute the script on the image we are dragging the icon over. And then just a final comment about how to make our script installable in PixInsight such that we can access it through the menu instead of executing it from the script editor or by picking the file externally. And at the very end, I would just talk about some guidelines I think it's good to follow in general when approaching a new script. And I will provide you some links with some resources that can be very useful at the very beginning, including, let's say, a set of different small scripts that basically will cover everything we're discussing now. So at the end of the workshop, let's say, you will be able to download them and review everything that I'm doing here live. The scripts are more complete, let's say, they are more commented, so you will be able to go through whatever we do here. later and taking your time to look again at the code. So my name is Roberto Sartori. I think some of you already know me, some other maybe not. I am a control system engineer. I'm working as an iOS and front-end software engineer, and I'm in astrophotography since 2018. So let's say I'm very young to the topic, but of course, as soon as I started doing photography and buying my first PixInsight license, I immediately discovered that PixInsight is strongly based on a open source project, and most of the scripts and the core functionality of PixInsight are available as an open source resource. And I immediately started playing with it and starting writing my first scripts. I'm probably most known from whom that knows me because of the WBPP script, which is a major project I worked in my spare time and the last year and a half, let's say. But I also made some upgrades to other scripts, including adding the new simple script correct magenta stars in collaboration with Eduardo Lucaradice. And other personal projects that recently I published. So I'm, let's say, continuously trying to improve and develop new ideas and contribute to improve the existing scripts. Recently, I also started a formal relationship with Astropleiade, a company that owns PixInsight. So I work as a contractor. And in this specific role, I'm porting, let's say, the most computational demanding algorithms from the CPU implementation to the GPU implementation in order to speed up the performances and taking advantage of this very powerful hardware. So what did I plan to implement for this workshop? We are going to create a very simple script that allows you to increase the saturation of an image, but instead of saturating the image using the color saturation process, we are going to perform a stretch on the C channel working in the LCH color space. So this is a slightly different way to increase the colors in the image, which has some advantages with respect to the standard color saturation increase in working in RGB space, because in the LCH space, the luminance, the perceived luminance, the colorfulness, and the hue are independently separated into 3 channels. So basically, by stretching the C channel, so the colorfulness of the pixel, we are going to increase the color of the image without modifying the hue and the luminance of them, right? So the result is slightly different with respect augmenting the saturation in RGB space. And here on the bottom, there is an example where we have on the top left the original image. On the bottom of it, we have the image saturated in RGB space, and on the right side, the saturation applied by the script we are going to implement, so by stretching this C channel. In terms of coloring, the result is slightly different. The hue is not changed with respect to the image on the left, so there are some benefits of this technique. And I thought it was a nice example because it's very simple. We can create a script that depends on a single parameter, but this simple script will allow us to discuss all the pillars, let's say, that we need to be aware of when we have to build a script. So the small interface we are going to create will contain a little description on the top. Then we'll add a drop-down that will allow us to select the view we want to modify. We'll add a numeric control, which is draggable, with which we can, let's say, increase the amount of saturation we want to apply. And on the very bottom, we'll add an execute button that will perform the saturation on the selected view. And moreover, we'll add also the well-known triangle that will allow us to drag this tool button on the workspace in order to create an instance of the script, or drag it on an image in order to execute it on the image we drag it onto. And in terms of the process we are going to execute from the scripting, we'll basically create an instance of the curves transformation process, and we will change the slope of this line in the C channel. And the amount of slope basically will depend on the parameter that we are setting in our interface, and this parameter just defines the distance of the point of the maximum of this line, let's say in this diagram. Okay, so we know what we have to do for the workshop, and we can start digging into the live coding session. So let me share PixInsight. Okay. Do you see my PixInsight?
Yes.
Okay, perfect. So now I'll just show you the tools that PixInsight offers for developers. In particular, there are two things that are worth to see. So first of all, we have a tab called Script Editor, and the purpose of this editor is just to be a text editor. It doesn't have anything special dedicated to the JavaScript language, which is the language we use for scripting in PixInsight. It allows us to create a new file, and here we can start writing our code. The nice thing is that once we want to run our script, we have this button on the right, which will save the file and execute the script immediately. Okay, so first thing we have to do is to save the first time our file. So I can call this my hello world file. Okay, it's an empty file, but it's perfectly fine to execute it, right? So if I click the button, the only thing I will see in the console is that the script is empty, so there's nothing to do. The second thing that we need to be aware is that we have this Object Explorer tab, which is, let's say, the main source of truth in terms of what is available in the environment we are coding in. We see that here we have two main groups: the core JavaScript objects and the external scriptable objects. The first group basically contains all the objects that are available in the language. So there are many, of course, the list is very long, and we see that there are some differences between them because some of them has a pyramidal icon and some of them has a spherical icon. So if you ask why is this, that's because the entries that has the sphere icon, this means that these entries are natively provided by the JavaScript language, while for objects that has the pyramid icon, these objects are provided by the PJSR framework. So they are provided by PixInsight itself. And we can see that in this list, we have one object that is called console. And this is very important because this object allows us to print something on the console. We can do also other things, but if we inspect the methods that are offered, we can see that we have, for example, this write function, or the version with the ln suffix, which means this will write something and move to the new line of the console. We have a warning function, we have a note function, and we have a critical function. These four functions are used to write messages on the console, but they differ because of the severity of the message we are printing on the console. So we can start using them and see what happens. Okay, so the object is named console. So the first thing we can do to use this method is to say sorry, Visual Explorer, script editor. Okay, so write my first hello world message. Okay, so very simple. We can say console dot write, and here it's write ln hello world. Okay, so if we are going to execute the script, okay, apparently nothing happened. Indeed, something happened. In the console, we see this message written, hello world, right? But it's awkward that we don't see the console while executing the script, right? So if you go back to the console, to the Object Explorer, we inspect the console object, we see that there is also a method called show. And as you can imagine, right, this is used to disclose the console. So if we want the console to be visible, we can say console.show and launch the script. You see now the console is first disclosed and then the message is printed, right? So to inspect what's the difference with respect to the other printing methods, we can use them and see what happens in the console, right? So we have the write-ln, we have the note-ln function to print, we have the warning, and we also have the critical.
Roberto,
yeah, tell me.
Very sorry. So this is case sensitive. I noticed that if I did not capitalize.
It is, yes.
Thank you.
No problem. Okay, so if we are going to execute this, we see, well, let me clear the console and relaunch it. It's better. Okay, so in this case, we have still for hello world, but the difference, and I think you're kind of used to these colors, right? Is that the function write is just used to log some, logging informations, nothing special, something that you think the user should know, but is not super relevant maybe. The note-ln function instead is used to highlight something. So this is more important than a standard message. So use it if you want the user to be aware of something, to highlight the message in the middle of many other messages that probably are outputted in the console. The warning message is has this how it's called, magenta color, and in general a warning, it shows an issue, but the issues is not kind of blocking the script, right? It's a warning, the script can continue, but you need the user to be aware of some issues that occurred. While the critical message is a very strong message and is intended basically to provide an information to the user that something critical happened before the script terminates, right? So critical message means I cannot continue, I have this issue, I'll let you know, right? So that's the context and the difference between this, the usage of these four methods. So that's the console and how we can print things in the console. And it's very useful. I encourage you to do it, especially while developing, since that we don't have a proper debugger. So we cannot, let's say, trace step by step our code, right? So sometimes you end up to write a lot of lines of code and you need to understand what's going on in the middle, right? So it's also a way to debug what's happening in the code while you're developing, right? So outputting things, variable values or stuff like that while in the middle of the code while you're developing, this is very useful, right? It's a way to trace your code.
Roberto, sorry, one question.
Yeah, sure.
The moment you hit the compile and run button, the script is saved automatically?
Yes, it's saved automatically and launched by PixInsight. Indeed, you always have this first line that tells you, I'm running the script, picking it from this path. Then you have another line that tells you, I'm processing the script, which means that if you have syntactical errors, your script will not even able to start. And then it will run. So in case of case-sensitive issues, they will be detected at runtime. But if you have syntax errors, for example, unclosed brackets or stuff like that, it will not be validated, right? So it will not even start.
Thanks.
Roberto.
Yes.
Can you do a step-by-step execution?
Unfortunately not. That's why I was saying that the only way you have to trace your code is to put intermediate console write in order to output kind of I'm here, now I'm here, now I'm here, or you can write, you can output some variable values at some points to trace the status of the execution.
Okay, thanks.
Okay, so another thing that could be interesting to know is that in this list, there is one special entry, which is called global. And this entry, in my understanding, it works slightly different because this global is not an object as console is and as the other entries are, but this global just collects a set of properties, so variables, and a set of static methods, so functions that are available in the global environment. This means that, for example, if you see here, we have these values, which are called core version major, core version minor, core version release, and core version revision. These are numbers that contains the PixInsight numbering version of the current PixInsight installation. And these values are injected, let's say, in our environment when PixInsight starts. So another nice example is to write on the console the PixInsight version we are running, right? So just to show you, I will remove this, and we can say core version is, and the first number we want to show, if you look at this, is the code name, core version code name. Okay, so it will not close anymore. Core version code name. Let me go to a new line. Okay, so if I execute this, I see that the code name is replay. And then we have the core version major, minor, release, and version and revision. So we can use all of them to build the PixInsight version. So we put a comma after the code revision name, then we say version with V, and we say core version major. Then we say dot, and we add the core version minor. Okay, let's see what's happened here. Okay, so now we see that this is PixInsight replay version 1.8, and continuing with the version numbering, we can add another point, print the core version version release, and at the end we can add a dash and print core version revision. So in this way, we are printing, and we know that this PixInsight is really reply codename version 1.8.8-7. It's just an example on how to access these global objects in case you would, I don't know, strictly rely on a specific PixInsight version, or for any reason you need to access to one of these global variables or global method that you have here. Okay, so
Roberto,
yeah,
is there the possibility to autocomplete the words while you're writing down the editor, or not?
No, not with this script editor. Of course, JavaScript files are flat text file, so you can in principle edit any script with your preferred code editor. And there are many editors that will provide autocomplete for JavaScript code.
Okay, thanks.
So he's not aware about the specific object that you have here in PJSR framework, but in terms of autocomplete JavaScript functions or function calls or parentheses and this kind of stuff, you can do it with other editors. For example, I don't use this editor. I use Visual Studio Code for writing scripts. So
perfect, thanks.
Yeah. Okay, so now let's dig into a bit more core aspect of scripting, which is the execution context. So when we execute scripts, we have basically three ways to launch a script. One way is to, as we are doing here, is to have the script in the editor and launch it by clicking the compile and run button, which is completely equivalent then selecting from the menu. I think you don't see my menu, right? Or just a little bit, just a piece of it. Okay, so maybe
it's
in this case you see it, right? On
yes.
the top left. Okay, perfect. This is the script menu. I can select execute script file and pick my script file from here, like that, for example. Or I can select a script from the menu. These three methods are completely equivalent in terms of execution context, and they launch the script in the so-called direct context. Okay, direct context means that the script is just launched from the menu or from the editor or from picking the file directly, right? So nothing special. And the behavior of the script in this case is basically to present a user interface to let the user to interact with the script. Okay, so this is the regular way we launch scripts from the menu. Another way is to rely with script instances. So now, just to create an instance of our script before, let's say, creating it programmatically, I will do a trick. So I will take the correct magenta star script and I will drag it on the workspace. Okay, this is creating the instance of the correct magenta star, but if I open this instance, I can play with parameters. So I can remove this parameter. I don't care about it. I have to remove this checksum, which means that if I'm going to run the script from this instance, I don't want to ensure that the script I'm launching is exactly the same script that created this instance. And now that I remove the MD5 checksum, so this kind of control, I can open another script, which is my hello world. Okay, and I can overwrite this instance. So this is a trick, let's say, to immediately create an instance. And you see now, if I click on the right and I say executing global context, this instance is going to load my hello world script and launch it. This kind of execution runs the script in the so-called global context. And the global context means that we are running the script from an instance, not generically from the menu, but from an instance, which means that this instance also embeds eventually some parameters that store the state of the script, right? But it's launched in the global context. It means it does not targeting any specific image. It's just launched, right? But it contains a state, let's say. While if we launch the script from the menu, it doesn't contain a state. And differently, we have the third way, which is dragging the instance icon to an image. And this kind of execution is called view target context. Okay, so with the target context, it means that I'm running the script from an instance. So I have a state inside of the script that I have to restore, and I'm targeting a specific image. So in this case, the behavior must be that the script silently executes on the image without prompting anything to the user, because the execution is expected not to stop. So when we build the scripts that are going to target images, most probably we want also to implement the creation of instances on the workspace. we need to manage these three cases in our script, right? So we must understand in which context the script has been launched. So now I'll show you how to detect if the context is the direct context, is the global context, or is the target context, and which is the image that the script is targeting. So let me create a new file, and I'll save it like execution context. Okay, to do that, I again will go to the Object Explorer because here we have an object called parameters. Okay, that contains some static properties that are exactly for us. So here you see that we have some properties. If we drag the mouse and let it there, I can see from the property definition that this is a Boolean parameter. Okay, and this Boolean parameter will be true if my script is launched in the global context. If not, this will be false. This Boolean property called isViewTarget is true if my script instance is dragged on an image, and so the context is the viewTarget context. So I expect my script in this case to silently restore the state from the instance and execute to the target image. And if this viewTarget is true, then the target view variable contains the view that needs to be transformed by my script. Okay, so let's see in terms of coding what we can do for that, right? So let's start structuring a little bit the code, right? So we can create a function called function main. And then here I want to still show the console. Okay, and now I want to detect the execution context. So the first thing I can test is if parameters dot is view target is true. Okay, so if this is true, it means that this is executing in view target context. Otherwise, if parameters dot is global target is true, it means that I'm executing this view in global context. Otherwise, this is executing in direct context. Okay, here I'm just defining my main function. So if I want it to run, right, I have to invoke it. So here I will say main. Okay, so if I'm going to execute the script, nothing will happen because I'm not printing to the console. But here we can say, okay, let's print it, right? So write ln, and here I will put the string, and I'll do the same for this one and for this one, right? So I'll take it here and go there and remove it. Okay, and here, same here, and this is the direct context. Okay, let's try to run it from here. We have a syntax error, so I forgot something. Let's see. Is target write ln? This is okay.
The semicolon.
Exactly. Same here. Well, indeed, in JavaScript, you don't even need semicolons, but I usually put them. Okay, so here is detected that the script is executed in direct context, right? Because I launched it from the editor. Now, what we can do is to open this instance, select my execution context script, update this instance. Okay. And now I can right click on it and click execute in the global context. And you see that the script here detected that we've been launched in the global context. And the third way is to drag it on an image, and the script detects that we are executing in the view target context. So we have a target view to modify, right? And if we want more details about the target view, once we are in target context, we can say, okay, if we are in target context, in the parameters dot target view, we should have the view. So let's print its ID, for example. So I say we say targeting, and here we add our parameters dot target view dot. This is a view, right? We go to Object Explorer. Let's search for it, right? We have an object which is a view. If I move the mouse on the target view, I see that this property is a view object. So let's see how this view object is composed by. So it has some properties, it has some method, we have some static methods, constants, constructor, we have a lot of stuff, right? But in the properties of a view, we also have the ID. And the ID we see is a string. Perfect. So we can say parameters.targetView.id. And I expect this to print the ID of the image I'm targeting. So let's save this file and let's drag it on the image. And here you see I'm executing on target view, and I'm targeting this image, which is _02_execution context, which is the ID on the image on top of which I dragged my script, right? So this is how we manage the understanding of the context, and we know how to behave, right? Because in direct context, we just launch our script with all the parameters assigned to their default values. If we launch a script in the global target, we just have to present our interface, but we need to restore the state embedded into the instance. If we are in a view target, we need to load the state embedded in the instance and apply the changes to the target image. So that's very important. Always manage it. So next step is to do something on an image, right? So let's see how to instantiate a process in the script and perform it on an image.
Roberto?
Yeah.
Before you continue, just
sure.
2 questions. So the red dots mean numbers and the green dots were strings. Is that right?
No, red dots means this variable can be changed by your script.
Oh, that's what that means.
You are able to change the ID of this view by assigning this ID to the view.
Oh, it's changeable, okay. So it's not
exactly
fixed. Okay.
It means read and write access. Differently, red dots means read only. You can only read this thing. You cannot change it.
Right. Okay.
Yeah. Thanks for the question. I forgot to mention.
Okay. Roberto, excuse me.
Sure.
The indentation is important in your script.
No,
like in
not.
Python, or okay, it's just for you an order.
For readability. Yeah. Okay, so let's take a process, in particular the process we are interested in. So I will take the curves transformation process. And I want, let's say, to play with this stretch in this C channel, right? So let's at a new point, I want a linear interpolation. I want to put it somewhere here around, right? Kind of 75. Okay, now by creating an instance of the process and right-clicking on the icon and select Edit Instance Source Code. This will provide all the code needed to basically instantiate the process which is done in the first line. So here to the variable P, we assign a new instance of curve transformation process. And here we see how to programmatically assign all the parameters of the process. So what I usually do if I want to integrate a process, I take everything and I'll put it in a function inside my script, right? So let's say that here we create a function called apply curves or apply LCH saturation. Let's say that I assume to receive the view that needs to be changed, and that's all. And in this function, I can literally pass the code. So here, our function is instantiating the process, setting some values, okay, and at the end, if we go to Object Explorer, we try to inspect how a process works, we are going to explore this section of the Object Explorer window, which is external scriptable objects, right? Here we have the full list of scriptable processes that are available. And indeed, we have our curves transformations here. And from here, we can, again, inspect all the properties. And also, we see here that this curves transformation object inner hit by the process instance. All the scriptable processes inner hit from process instance, and this is a container of some common methods that all the processes have, right? And in the methods, we have a method which is called execute on. If you go here, we see that the arguments are a view. As an optional second parameter, we have this swap value, which can be true or false. So probably I'm not sure about the meaning of this value. I assume that this means keep everything in memory. Don't swap it to the disk while we are processing the image. And the result is a Boolean, which is true if the execution has been performed without error, or false if some error occurred. So let's add our execution here. So I say p.execute on, and here I want to execute my process on the view I'm passing to this function, right? Okay, so we can try it. In this way, we have the process here. Let me give them a meaningful name. So this is LCH saturation, and this is my script. Okay, let me bring in an image. Okay. So first of all, I will save my script, and I don't have to forget one thing. We are now testing, let's say, the view target context. So we say if the script is dragged on an image, we want to perform the saturation. So here we don't have to forget that we have to call our apply LCH saturation to the view. So we call the function, and what we pass is our view, right? And set saturation like this. So save the script, and now we have, let's say I've made 2 copies of this. Okay. And on the first, I will apply the process. And on the second, I will apply the script. Perfect. The result is the same. Here in the script, we detected that we have been launched in the target view context. We know the image. We applied the process. And if we look at the history of the 2 images, we'll see that the two histories are perfectly matching. And this is because I mean, in general, PixInsight is not aware if a process is applied by a script or by the user, right? He just knows that this process has been applied to the image. And so this is going to change the history of the image. So that's why both histories of the two images are exactly the same. Okay, so now it's time to interact with the user and to let the user to tune a parameter and somehow use this parameter to tune the level of the saturation we want to apply. But before talking about how to create a user interface, I would like to have a quick talk about the interfaces using some slides. So let me share the presentation. We were here. Okay, so basically, I want just to quickly talk about two things, right? The first thing is that a user interface is basically organized with a tree structure, right? So we have the main, let's say the main component, which is a dialog. And this dialog is the parent of some child components. Our interface is pretty straightforward because we have one single dialog and all the controls that we are going to add are just child of this dialog, right? So we'll have a dialog and we'll create some child controls, which are the text box, which is the element on the top that contains some rich text, the view list, the numerical control, and the push button and tool button. But keep in mind that this tree structure in terms of parent-child relationship between the component is not the same as the layout structure is. So laying out indeed is something specific regarding how to position and size the elements in the user interface. And to do that, we make usage of the so-called sizer object responsible of organizing the component. So in our very simple example, this is the structure of the component, so the dialog and the child elements. But to create this layout, we need, first of all, a vertical sizer. And a vertical sizer, as soon as we add elements to it, it will lay out element from the top to the bottom, spanning the whole width available. So the first object to be added will be on the top, then we'll add a second object and so forth, right? From the top to the bottom. Differently, on the very bottom, we have the push button and the tool button, which are kind of in the same line. So as a fourth element in position number 3, we are going to add a horizontal sizer. And to this horizontal sizer, we are going to add the button, an element that is kind of stretchable, and then we add the button. And the horizontal sizer lays out elements from the left to the right. And the layout tree, as you see, differs from the structure tree, let's say, because we basically are going to create a vertical sizer that contains first a text box on the top, a view list, numerical control, and then a horizontal slider that itself contains, again, a tool button, a stretch element, and the push button to create this layout. Okay, perfect. So the first thing we have to do is to create a dialog. So to do that, we create a dedicated function to show the dialog, right? So we call it show dialog. Okay, and we say let dialog equal to new dialog, and we return. Sorry, the return of this function is dialog.execute. Super simple. Execute, I mean, dialog, of course, is an object in the core JavaScript objects. So we have this thing, okay. Dialog, we have it here. And we see in the methods, we have the execute function. This execute basically presents the dialog. And one important thing is the control flow. Basically, when we call this function, we first instantiate the dialog and then we show it. But when we show it, the execution control will stop here. The control will be given to the dialog itself, and the user will be able to start interacting with the components. And only when we will dismiss the dialog, our script execution will continue. Right, so here we create our main function, and here let's say that we want to keep the return value of this show dialog function, and we want to print what is returned. Console.write and return value, and the returned value is ret val. Okay, and then we call our main function here. So the main function will call the show dialog function. This will present the dialog, stop the execution, wait us to dismiss it, and once dismiss it, we will receive the returned value and we'll print it. Okay, so this script is going to create this empty dialog. And once we close it, let's go here, we see that return value is 0. We'll use this value later. Okay, so now we have to populate the dialog. So to put controls in it, right? So to start structuring it, is not enough to instantiate a dialog. We need to create a custom dialog that we want to populate. And to do that, we do this. We create and this is kind of standard practice, right? So we create a function and we give the name of the dialog object that we want to instantiate. So this will be our LCH saturation dialog. And this function needs its prototype to be assigned to a new dialog object. Okay, so this is something very JavaScript related. So for whom are already comfortable with JavaScript, maybe this is more clear. For whom that don't know exactly what's going on here, keep it as a kind of standard practice, because in JavaScript we don't have a proper, let's say, object inheritance. So this is a way to inherit from the dialog objects in order to create a custom dialog object, right? That's the way in JavaScript we can achieve this kind of inheritance. And another, let's say, kind of adopted practice that we do in all PixInsight script is that the function that represent a dialog customization do this at the very top. And this, I mean, these two code of lines are basically a way in JavaScript to say this: when I'm going to create a dialog, this dialog object will be merged to every function and properties that a dialog has. Right. So in order for my custom dialog, which is a custom component, to have a dialog as a parent, it must inherit all the properties that we see here, all the methods, all the constructor, event handlers, and so forth. And that's the way we do it. So say that this is a kind of a standard starting point to create a custom dialog. Now we can start creating new controls and add them to the dialog. So the first thing that we want to add is the text box containing the title description. So just to be quicker here, I will copy and paste some code. So here I'm creating a title variable that belongs to the dialog, and I will instantiate the text box. And this text box, every time we create a new component, we need to pass as an argument the parent of its component, right? And by using the keyword this, we are saying that this is a child of my main dialog. And now that we have the title, the text box object, if you look at it here, text box, okay, we have it here. We see, for example, that we have several properties like read-only, for example. We don't want this piece of text to be editable. So we say this title dot read only equal to true. Okay, and we can even start launching the script and see what happens, right? But of course, in here, we don't need to instantiate a new generic dialog. We want to instantiate our custom dialog. So we need to create a new instance of my LCH saturation dialog. So if we launch it, we see this thing. This thing, if you notice, is slightly different from the previous one because it contains my description objects on the top. For example, other stuff that we can set is its background color. Maybe we don't like it, so we could put some colors here, like this one, a bit darker, just a bit darker. Maybe we can say it must have a minimum size or width because we want to have it a fixed size, right? So you see here it's smaller, enough space to contain the text, and then we can populate the text by using the text property.
Roberto.
And, yes.
You mistyped the background color method property.
Yeah, you're right. You're right. Background color, right? Ah, perfect. It works, right? Okay, so let me go here. Let's remove this background color. It's very bad. Okay, and this is and as a text property, we can set I mean the string that is going to be printed, right? Keep in mind that every time we use text properties, they are kind of rich text compatible. So we can use a syntax to create bold text, for example, like here, or create a new line. And in this way, you see, we've created a bold text, we create a new line, and then a small description. Okay. The next step is to create the drop-down element that will list the views that are in the workspace in order to pick one of them, right? So to do this, create my view list. And here is script type, title and description. Okay, I want to assign a variable called view list, for example, and view list is again one object. The view list is this object, view list here. If we open it, we will find something interesting in the methods, because you see that here we can say get all to retrieve every view and every preview listed. Or maybe you are just interested in retrieving only the main views, so the previews will not be listed. Or maybe we want to list only the previews and discard the main views, right? We have different options to populate this list. So we create the object, view list, the parent is still this. And then we need to populate this list, right? So the first thing we have to do is to choose with which method we want to populate it. But in our case, we are just interested in maybe gathering all the views, right? So, or maybe it doesn't make sense. It doesn't make sense to have everything. We can just pick only the main views, right? So get main views. Get main views. Okay, this is going to populate our drop-down automatically, and it will list all the views that are in the workspace. Okay, and that's basically all that we need to show this control in the dialog. So if we run the script, we see something weird, right? This happens because we added the drop-down as a child of the dialog box. So it's visible, but we didn't manage to create a sizer in order to lay out the controls in the view. Okay, so now it's time to deal with the sizer and lay out these two elements properly, right? So what we have to do here, well, in general, the dialog or every control, we can see it from the Object Explorer, right? If we go to the dialog object, I'm just playing a lot with this Object Explorer to show you, how to find things, how to inspect objects, and to better understand if you have question, does this contain this property, does this contain this method, whatever. This is something that you really have to practice at the very beginning to gather information, right? So this dialog object, inner hits, it doesn't have anything special called sizer in the properties, but it inner hits from control, right? So maybe this superclass has something more interesting. And indeed, it has it because it has a property called sizer. This means that every control inside the dialog box has a sizer as a property, right? So we can use it to lay out the components because we can say this region represents my dialog. Sizer equal to a new vertical sizer. Okay, it's not enough to instantiate a new sizer for the dialog. We need to add elements to the sizer, which are the elements that will be managed by it. So I have to say this sizer dot, and what can I do with the sizer? Let's inspect the sizer object. Okay, with the sizer, we have some method, and we have a simple method add, right? And we see that the first argument is a control object. So it expects some objects to be added to a sizer. So we say, okay, let's add the title. And then let's, above. And then let's add my view list, one after the other. Okay, and now let's see what happens. Good. Now they are kind of laid out, right? But let's say, okay, we are not happy enough, right? Because, we want to have some margin, let's say, for example, some distance between the controls and the dialog borders. So if we again go to the Object Explorer, we look at the sizer, we see in the properties that we have margin property. So let's use it, right? So we say, okay, sizer, we want a margin to be 20, for example. Let's see what happens. Good, I've added some margins. But now let's say that, for example, I'm not happy of this, displacement of the object that goes up and down, right? I want them to stick on the top. So what I can do is to add a stretch on the bottom. And the stretch on the bottom basically will say, I let the other components to have their natural height, and I will stretch to occupy the remaining space. So if we say here, again, Object Explorer, Object Explorer, methods. Here we have the function add stretch, which is exactly doing what we need to do. So we have add stretch. It maybe is very high. Let's put 8. So by doing this, you see that if I expand vertically my dialog, the stretch element we added at the bottom will stretch itself, but the height of the above components will not be affected, right? For example, here you see that we can contract horizontally the dialog. By doing this, the text inside the text box gets too long, right? And we start scrolling it. Maybe we don't like it. So what we can do is to force the dialog itself not to have the width less than a certain value. We can close the dialog, go here, and we can say on the very top, okay, this is my dialog. By I say, well, let's forget the scale for a moment. I want my minimum width to be at least 340. By doing this, you see, I cannot compress horizontally the dialog anymore. And this is, let's say, acceptable because that's the minimum width I need to have in order to give enough space on the text on the top, right, to stay there without scrolling inside. Moreover, I want some distance between the elements here, right? I don't want this drop down to touch the text box on the top. So to do that, between the title and the list, I can add something. Let's see what I can add. I have spacing, and spacing is adding a fixed space. So I'm saying, okay, in this vertical organization here, I want to add some space, like, I don't know, 8 pixels. Oops, sorry, I mistyped something. Oops. Spacing, not space. Okay, so it's spacing 8. And now I have my text box on the top, some space, and my drop down. And consider that my drop down is already populated by the main views. So you see that step by step we are getting closer to an interface that is usable. The next thing that we have to add.
Roberto, because
sure,
it's wonderful that you can do this quickly, but does there exist, I mean, this seems like a template. Someone should just construct a dialogue with basic things and then you can edit it. Has anyone done that, or am I just gonna have to copy your work?
Not as far as I know. Indeed, if you look at the open source scripts, you will find a lot of code spent on building in user interfaces.
Yeah.
And we really need to instantiate any component, set any property, add it, and build programmatically any detail of the interface. Okay, so perfect. So let's go on. And the next component opens a small parenthesis that sometimes need to be discussed because the next component is the numerical control. So here we have, let's say, a numerical control. This is the component that is represented by a label, a numerical entry, and the slider, right? And they are kind of coupled each other because you can put the number inside the text box and the slider will move accordingly, or you can drag the slider and the number will update accordingly. So let's start playing with it. And here, that's my view list. And that's my create my numerical control. So this is, let's say, the amount of saturation. So I will call it set amount new numerical control. and the parent is this. So this is inside my dialog box, numerical control. Okay, good. And let's add this numerical control to the sizer. So we want to add, again, a bit more spacing. And then we want to add it, sorry, this one, numerical control. Okay, so just below the list, we add a bit more space. And then we add to the sizer our set amount control. If we launch it, now we have an issue. You see, numerical control is not defined. This means that despite the fact that numerical control is listed into the JavaScript core objects, somehow it is not defined. If it happens, we have a way to understand where to pick this object from. And I'll show you here, well, I'll show you first how in general I do the search, right? So what I do is move into the script folder. You can access to the scripts folder you have in your PixInsight installation, or maybe you already checked out the open source repository, so you have another folder, whatever it is. I start from here and I say, okay, where is my numeric control? Okay,
Perfect.
so basically I moved inside my PJSR, I mean the folder that contains the scripts, being it the default installed by PixInsight or the open source, doesn't change. I search for numerical control string, and I see that there are a lot of scripts that are using numerical control. And this can be also nice to sometimes to look for a control and see how the other scripts are using it. You learn a lot by doing this. But here, the important thing to notice is that I found this file, numericalcontrol.jsh. So this is a file that basically contains the definition of this control. And if somehow a control is not defined, what we can do is to import this header file in our script. Okay, so this is the line of code that you need to add on the top of your script to say you had to include something, so embed something that comes from an external source. And what I want to include from the PJSR framework / and the file that I want to import is numericalcontrol.js. This will import the code that defines the numerical control object. And now when I will run my script and I will land to this line of code, numerical control keyword will be defined. It will exist. Maybe I didn't say it, or maybe I mistyped the file. Let me see, include numerical control.
Maybe it is numeric control.
Numeric, isn't numerical? Did I mistype it? Numeric control.jsh.
It's in the
sorry.
object execution.
You're right. You're right. So let's redo the test without this line. Okay. So in this case, numerical control was defined, but for one specific reason. I previously launched once my script with this line of code active, let's say. So the point is that if you launch one time a script that includes this file, the object is imported and it will exist until PixInsight will get closed. Okay, so I mean, for the demo, it's a bit tricky. I should close PixInsight, reopen it, relaunch the script, have the error, and re-add the include, right, to show you that that's the flow. But in general, everything I talk about is valid. So if you're missing some objects, you need to search for the JSH header file to be imported and add your include on the top. If you launch the script, this file will be imported into the environment, and the definitions that are in that file will exist until PixInsight is closed. So it's very important to do a final test of your script. You really have to close PixInsight, open it, and run your script as the first script that is launched. So this is a test that you always have to do. Okay, so I will leave this include on the top because it's needed. And now we have our numeric control accessible. Okay, it's good, we see it here, but of course we have to configure it, right? So he doesn't know what is the range of the slider. There is no text, there's nothing, right? There's just an empty component. So let's customize it a little bit. Okay. Interesting to see that our numerical control, where are you? Here. Inherits from this numeric edit component, which as properties has a label. Okay, so, and the label is a label component. So it's this component, which has as property text margins, use rich text, and so forth, right? So if you want to add a label to our numerical control, we have to say our variable dot label dot text. And we can say amount of saturation, for example. Okay, let's run it. And now we have the label on the left. Now we have to set the ranges, right? And to set the ranges, we have the method setRange, and we say the range goes from 0 to 1, and this is the range of the value that is stored in this control. Now we, so basically, okay, let me just clarify. This is the value of the number that we'll see here, right? So we cannot write 2. 2 is an error. Our range goes from 0 to 1, right? So we can put 0.5, that's fine. -1 is not fine, right? -10, error, not a valid range. So once we set the range of the values we want, we have to let's say describe how the slider works. So to do that, we can say we can set the range of the slider. So again, if you go to Object Explorer, we look into the numeric control. We said that we have a property that is called slider, and the slider is a horizontal slider. And the horizontal slider is this object here, horizontal slider. I disclosed the wrong one, okay. And this is inherits from slider and its properties. I have some functions like the step size, a min value, a max value. We have a lot of controls on that. And as method, we have the set range. So we basically are going to say the slider here has a range, let's say from 0 to 100. Okay, and we want also to add a kind of precision. We don't need such amount of zeros when we see the values into this label, right? We just need, I know, kind of two digit after the comma. So we say set precision to 2. Okay, by doing that, we have a slider that has a range with 100 values, and we have a value displayed in the edit text box, which has 2 digits, right? So let's say that it's fine, the behavior, so we can accept it. Make sense? Okay. So we are close to finish the user interface. We need to add the tool button and the execute button. So let's say this is my execute button. Okay, so you got the concept. So I think I can speed up a little bit here. I'm just creating here a push button. I assign this execute label and I say this has a width of 40. I'm just defining a fixed width. Then I want to create a tool button. The tool button has an icon embedded here. And this is, let's say, a standard way to pick up the diagonal icon, right? So we use the dialog scaled resource method. And here we have a kind of standard path to retrieve icons provided by PixInsight bundle. So this is how access to the blue triangle icon, and we set it as an icon to our tool button. Now, of course, we have to create the horizontal slider. We call it, let's say, bottom sizer. And this is a new, this time it's an horizontal sizer. Yes. Okay, again, here we want some margins because we want things to look nice. So it will be margin equal to 8. And we need to add things to it. So we say add. We want to add the tool button first. Then we've learned that we can add a stretch. This time it will be horizontal stretch, and then we add our push button. And then we don't have to forget, then we want to add this horizontal slider. So here again, we are going to add more spacing, and we are going to add our horizontal sizer here. So in the vertical organization, we have the title, the view list, the numerical content, and the sizer, which is horizontal, that contains the instance button, some stretch, and the execution button. Exactly the layout tree that we saw before in the slides. So if we run this, we have the interface built, right? Okay, at this point, we need to somehow hook to the events that happens in the screen. So for example, if I change this value, I want to store it somewhere. If I want to execute this, I want to take this value to use it in my process instance in order to be applied to the view that is selected here. So let's add some business logic to the user interface. So to do that, we need, first of all, an object that contains the parameter of the script. So we want to create, let's say, a global variable called LCH saturation, CH saturation parameters. Okay, this object, okay, this is the JavaScript syntax to create an object, will contain, let's say, saturation amount. This parameter, which is the saturation amount, equal to 0 at the very beginning. And let's say that we also store which is the target view that we selected from the dropdown. So we need to add a target view, which at the very beginning is undefined because we don't know what target view will pick, right? So, okay, this is undefined. And that's pure JavaScript object. Okay, so we run it to ensure that we don't have any syntax error. Perfectly fine. So how do we react to the user interaction with the dialog? Basically, what we want to have here on the numerical control, we want to say every time the user drags the slider, I want to store this value. So I say this set amount dot on value updated, and on value updated can be found here, numerical control, numeric edit method. This time the numerical control has one event handler which is triggered every time the value changes. So every time I drag the slider or I type something, okay, this on value updated is called, and to be called it needs to be a function. So we have to define it as a function. So we say this property is a function that receives a value, and we can see that it receives a value still from here, because if we point the mouse, we'll see the definition of the function. So it accepts a number as a parameter. And what do we do when a value changed? We say our LCH saturation parameters dot saturation amount equal to value. So basically we are saying every time the slider changes, we take the value and we store it in this variable here. Let me ensure that this name is not mistyped by pasting it. Okay, we also can play with the console dot write ln here and say new value here. So we are printing to the console the new value that we have from the slider. Okay, set amount. Sorry, which line is this? Maybe it's a mistyped. 34 on body update. Set. Okay, I mistyped the variable. Okay, so you see, if you drag it, it doesn't print. Okay, there's a mistake. Which
there was a typo.
Right. You're right.
The name of the function, right?
Yeah. Right ln here, this one. Okay, we show the console. Okay, and here we see every time this value changes, we print the value in the console. We ensure that this is an example how to, let's say, how to track what's happening in your code by putting things in the console, right? So you are aware that your value, the value you are capturing, is correct. Okay, so we don't need this output, of course, anymore. We remove it. So first of all, we capture the value. Now, let me see. We have to store the selected image from this list. Oh, I hope it did not break again. Okay. And to do that, we need to understand which is the event handler offered by the view list. So let's search for it. Methods. We don't have. Okay, here we have an event handler on current view updated, on view selected. So the good name looks like to be on view selected, right? And you see that on view selected, we receive a view as an object of the function. So let's implement it. View, where is the view list? Very good. So on this view list, on view selected, this is a function, and this takes the new view, well, the selected view, let's say, and we say this dot, it's called target view equal to view. So we are also storing a reference to the selected view. And let me just do console, all right, ln, this time not mistyped. Selected view, and we say view.id. .id, okay. So we also print the ID of the selected view. So we say this one, execution context, perfect. If I change it, the console, perfect. So this looks correct. So now we got the value and the view. I think we are ready to implement the execute button behavior. But the execute button behavior basically just needs to dismiss the dialog. And we see why just in a few minutes. So we say when this on click, this is another event handler specifically related to the buttons. Well, this is one specific syntax of JavaScript using arrow. Let's say the definition of a function with an arrow instead of a function, because defining a function in this way maintains the same context of the object it's assigned to. This means that if here I say this dot something, it means that I'm still referring to the same this that is outside. So this point something means the dialog object. Okay, so I say this dot okay. Okay, and okay is one method of the dialog. Dialog, okay, we see the methods. We have several methods: cancel, done, execute, whatever. Okay, this is a method we can call to dismiss the dialog, right? So we do it. This means that on the bottom here, our script is going to return. So if I run it, I do something, I select something, I click execute. The script returns and I see that the value is 1, which is different from closing the dialog, because if I close the dialog with the close button, the return value is 0. So in this way, the return value allows us to distinguish between the case where I selected to execute my dialog with respect to the case where I just close the dialog without executing anything, right? So we'll use this return value for that. So I would say here, if my return value is 1, I need to perform my transformation. Otherwise, dialog has been closed, just closed, dismissed, canceled. Okay, so just to check if the data is there, I want to write in at that point what is my view ID. So I will take my global variable LCH stat parameters and say saturation amount, set amount, and the ID of the selected view. So target view, my target view is target view dot ID. Okay, let's execute it. I select the first image, I put 0.14 and execute it. And here I see the target view is not defined, of course, because it has to be my global variable dot target view dot ID. Okay. Okay, so here you see that once we dismiss the dialog, we stored, let's say, in our global variable, the saturation amount and the view ID. Basically the view object, we are just printing the ID of this object, but we have the object itself, right? So we have the possibility to process it. So let me re-import the function that we've created for the curves, right? I will just copy and paste. It was this one, right? So if you remember, we called it apply curves. It had only one view, and it was something like that. So it was creating the curves transformation, setting a parameter, in particular modifying only the C curves, and saying that on the C channel, the interpolation is just linear between the points, and then it executes the process on the view. But this time we have one more information. We have the amount, and we want to integrate it in our curves. So what we want to do here is that in our apply curves function, we add another parameter, which is which we call amount, and we'll use it to differently interpolate the curves. So instead of having a fixed curve, we say, no, we want this point, which was the X point of the maximum of the line, to be 1 minus amount, right? This means that if we leave the amount to 0, this line will be unchanged, basically. And the more we are going to increase the amount, the lower will be this value. This means that the more the maximum of our linear interpolation curve will move to the left. So it will increase the saturation. So in here, what is remaining is to say, okay, now I want to apply my curve. Apply curve. And here we want to pass the target view and then our amount. Okay, let's try it. I need an image. So I will take again the previous one. Okay, so go to the script, open my interface, put something kind of 25, which correspond to the same transformation we saw in the example in the slides. I'll take my triangle galaxy and I say execute. And bam, we have it, right? Our script performed our linear transformation. And we can see it by the history. We see the curves transformation. We can even open it and see that the transformation exactly corresponds to what we expected, right? So we've set 0.25 as an amount, which means that we decreased this point from 1 to 0.75. We can also go here and inspect with the inspector. We have exactly the X value of 0.75, which was the expected value. Okay, so what is remaining in terms of interface? Two things. Currently, we didn't manage the creation of the instance. And in our script here, the main function I wrote is not managing the context execution. So first of all, let's manage the execution context detection. So even before creating a dialog, we must say if parameters dot is global target. Okay, if this is global target, I need to load my parameters and show the dialog, right? But probably even better, before I can say if parameters dot is view target. This means that an image is available. So I need to apply. Well, let's first write all the flow. We have the view target, we have the global target. Otherwise, we can do what we did before. Now we want to create an instance, and to create an instance, we need basically to store the state of the script once we create an instance. And to store the state, we are going to do this. We need to interact with the parameters object again, because there are some functions that are meant exactly for that. On the methods, we see that we have a set method, and this method accepts a string and an object value. So what happens when we set something on the parameters? Basically, a key value table is created, and this table is automatically saved and embedded into the instance once we create it on the workspace. And this table is again accessible when our script is launched from an instance, so we can access this table and read from this table the values that has been stored once the instance was created.
So like a dictionary?
It's exactly a dictionary, or a map in C++. It's basically a key value table. So to do that, it's a personal preference how to do it in terms of coding, but I would create a save function here. Very simple, which says, if I want to save, I basically need to store the saturation amount. That's the only parameter I need to know about if I want to reload the state of my script. So we say parameters dot set. Here we say set amount. So this is the key, and then I have to provide the value, and the value is again this one dot set amount, saturation, sorry, not set, saturation amount, and the same here. So I'm populating the table and saving my parameter. Okay, so my save function will do that simply.
You have a little typo there.
Where?
Parameter.
Parameters. Okay, thank you very much. Okay, now I'm able, if I invoke this save function, this will prepare the table that will be saved with my instance. Now I need a function that reloads the table on the fly if needed, right? So I will create a load function. And this time the reading is slightly different. Basically, the choice made in the framework is that parameters are always saved as strings. So the problem is that when we are going to read it back, we need to know what kind of data is stored into the string as a value. So we need to say, we can see from the parameters object that the get function, we have a generic get only for strings. So the generic get is able to read a string, but if we specifically want to return a real number, we need to convert the string to a number. So we need to use the getReal function. So we say we want to reassign my set parameters. So I want to say LCH parameter dot saturation amount is now equal to parameters dot get, but not the simple get, otherwise I would assign a string, but I want a number. So I say get real, and the key that I want to read is the saturation amount. That's the function. One important thing is that when we load the values from the instance table, it's not guaranteed that the values are there, because the table can be manipulated, or even more, the script instance could be very old, and maybe this parameter was not saved with the version of the script that created that instance. So we always need to check if a parameter exists when we want to load it. So to do that, we just have to say if parameters.has and the key name set amount. So if set amount exists in the table, then I'm going to read it and assign it. Otherwise, I will leave the set amount parameter unchanged. Okay, and this is the load value. So now that we are able to write into the instance table and load data from the instance table, it's time to create the instance. And to create the instance, we are using the tool button. In particular, we have a method on the tool button. Again here, tool button. Okay, we have an event handler, which is called, there is this on mouse press. I usually use this one. So on mouse press, we can do something. So when we click on the button, something happens. So we say new instance button dot on mouse press. That's a handler. So we have to say this is a function. Okay, again, I need to use the arrow because I want to access to the dialog within this function. First of all, I want to save the parameters in this moment. So this will be lch set parameter. Let me just copy the name to not to mistype it. Okay. Saturation dialog dot. This time I can call save. And now I have this method that belongs to the dialog object. Dialog object here, which is called new instance. And that's the key method to call. New instance. Okay. Okay, that's all I need to create a script instance. It's very simple.
Robbie, you have to remove the n from the method because you call the method on mouse with n. You can see the new instance button dot on mouse. You have to remove the n.
On mouse press.
Okay,
that one.
Perfect.
Thank you. Okay, so we have the script. Now it's time to click on the button and drag it. Okay, it doesn't work. Probably there's an error in the function. Exactly. And we can see it from here. So at line 84, there's a type error. Save is not a function. Okay, I just mistyped something. So in my object, I'd call it save. Let me check the syntax. Save is correct. It's a function. Maybe I mistyped the name here. Of course, it was the wrong variable. So my global variable is lch set parameters, and I have to use it, okay, in order to access to the save function. Perfect. So we do it. Let me clear the console. I don't like it. Okay, so now we can drag. Okay, this is what happens when we call the new instance method of the dialog. You see that I am still dragging, and here I can do two things. I can raise my finger, leaving the icon on the workspace. This is going to create an instance, or I can drag this icon and leave it here. This is going to create an instance and launch the instance on the target image. The instance then will be removed. It will not stay on the workspace. But this means perform the script with a target image. So I don't want to do it now, but at least here we were able to create a script instance. So if I double click here, you see that here the instance table contains a value that has set amount as a key, and the value is 0. This table is editable, and we can see it from here. We can change this parameter to 0.7, for example, and resave it and overwrite our script instance. Now we have an instance, so we can drag it and apply it to an image. Let's manage the case where we have a target view. So we say if there is a target view, we have to do two things. The first is that we have to reload the parameters from the instance table. So we have to call the load function. That's fundamental because we are starting from an instance. So we say load. And now we are able to apply the curves here, saying that the view that we are targeting is parameters dot target view. Okay, so we apply the curve to the target view with the saturation amount that was stored into the instance, and that's all, right? This will exit, and this will exit from the script. So we save it. Now we can drag it. Okay, we have something. Of course, there's a problem because the checksum has changed now because the source code has changed. I've made a change between the version that created the script, which was before my change, and the version that now is executed. So let's get rid of this instance and let's recreate a new instance with 0.25. Okay, this is created. I can drag it. Okay, and this executed the transformation. I see that my script performed this curve transformation with expected saturation curve. The last thing that is remaining is what to do if I execute my script in global context. At the moment, the script is doing nothing. Probably in this case, it makes sense to say, if I'm targeting a view, I apply a curve and I return because I don't need to do anything else. Otherwise, if I'm a global target, I still load my parameters, and then my script can create the dialog and continue. Okay. This is also kind of general flow that we can follow, right? So now if I'm running the instance as a global target, let me save it. This will raise an error because the checksum has been changed again. So let me remove it, create a new instance, close it. Oh, I didn't drag it. Okay. Now, if I right click and execute in global context, okay, there's one thing that is missing here. In order to really reflect on the dialog, the status of the loaded parameters, which is that we need to initialize the numerical control to the value stored. Okay, so let me do it. So here, when we create the numerical control, I think we have the value, right? Let me see, numerical control, numerical control, slider, properties. We have this, the values. Okay, maybe you have a function to set the value. Set range, set value, perfect. Okay, so we can say we create it, we set the range and whatever, but at the end, maybe for this one, we say this dot set value, and as a value, we set the current amount. So this is saved, okay. Set value is not a function, okay, just quickly to see numeric control. So maybe I mistyped it.
I think you're missing a set amount after the this.
Oh my God, again. Okay, thank you very much. Numerical control, saturation amount, set the amount. No, sorry. This, of course, set amount dot set value, like that, right? Okay. Let me delete this one. Executing global context. Okay, I forgot to change the value. So let's say 30, we override this one. Yes. Oh, something bad happened. Okay, you see that the script is launched. The value is updated to the value stored into the table. Even if I do this, I think set amount to 0.5, just as an example. I can update this table just to be sure. I can rerun in global context, and this is 0.5. Okay, so this is showing the value stored into the script instance. So the script is restored, let's say, if launched in global context. Right? How can we make this script installable? Because at the moment, this script will not be recognized by PixInsight if we want to feature it, right? So when we go to the script, under the script menu, we go to feature scripts. We are able to, let's say, add new scripts. We have to pick one folder that contains our script, and PixInsight will read all the JavaScript files, but it will look for special keywords inside the script that tells PixInsight the name of the script and the path of installation within the menu under the script main menu entry, right? To do that is very simple. We just need to add a couple of informations on the top of, usually they are on the top of the file. So on here, after the include, we need to say hash feature dash ID. And here we have to specify the path where the script is expected to be installed. So in this example, I want this script to be under utilities, and the name will be LCH saturation. And feature info is a description of the script that is listed in the featured scripts. So basically in here, right? So let's try to feature the script. So I want to save it. Now I'll go to script, feature script, add. The directory is this one. Here I have my dialog file. You see, oh, 2 additional scripts. Probably it recognizes also the other. But if I look at the list here, I should have under my utilities, LHA saturation. Okay, so let's see why we have 2 scripts. One, cool, because it's recursive. So it found my dialog file, and then it also went in the subdirectories, and he found the other version of the script that I published on my GitLab repository to be shared after the workshop, which also contains some description to be installable. Okay, so now under script utilities, I have this the script under, it was called LCH script utilities should be here. I don't see it here. Maybe, I don't know. My fear is that there is a conflict because of the presence of 2 scripts with the same name. But let me just try to unfeature one of the 2. Okay, just here. Okay, now my script, only one script was detected, and search my script is okay, and it's here. Under utilities, LCH saturation, I should find my script. I don't know if this space creates confusion or not, but I don't think so. I click done, script, utilities, LCH saturation, it's there. So now I can launch it also from the menu, and my script is there. I think we covered everything that was worth to cover. Let me just quickly go back to the presentation. I just have a few notes. First of all, I prepared some resources to share with you, and for sure this presentation will be shared after the meeting. For whom that wants to, have some documentation specifically on the JavaScript language, my personal reference is this URL, which is the MDN JavaScript official documentation. The other thing which is worth to look at is the PixInsight Open Source repository. This repository contains all the scripts, but on the open source repository, you can become a contributor. So if you are developing and you complete a script that would be onboarded, you probably would need to access to this repository and upload your script there. So forum, if you have questions, if you want to share concerns or whatever, you can follow the forum section of PixInsight dedicated to developers. There is also one suggestion. Follow the new script announcement section of the forum. Here, when people have new scripts and they want to announce it, usually they create a post here. So you are encouraged, if you end up to something that is shareable, go there and use this place as the first place to start sharing your code. And also at the end, you will receive a link from which you will access to all the scripts. They are subdivided by topics, and basically they contains the code I wrote live in this workshop, and the code is more commented, probably better organized, so it's easier to follow. It's a reference for the future if you want to get back to the topics we discussed and refollow what I've done here with this simple script. Some very quick guidelines that I think should be nice to follow. As you saw I took the time and I spent a lot of time exploring the Object Explorer tab. Practice this thing at the very beginning, because at the very beginning it's very easy to get stuck and have no idea how to do something, right? So inspecting the objects, reading the methods is very helpful to get a better understanding on how an object works. Moreover, that's not the only documentation. Most of the time, the only concrete way to understand how to use or how to do something is just to see how other scripts perform some operation or uses some components, right? So also the open source scripts are a very, very precious resource for documentation and for understanding how to do things. Use the console message is very important. Otherwise, your code will run blinded and you don't have idea. If something is not working, you have no idea why it's not working. So the only output you have is the console. Use it while developing. And once you finish developing, remove your log messages and leave only the message that are useful for the user. Manage the execution context. So always understand if the script runs in the direct context, in the global context, or targeting an image, and behave as consequently. Interfaces. We spend very few time indeed talking about interface. There is way more complexity the more your script has parameters, and try to first design it on a paper. I usually do that. I use a sketching software. I try to mock, let's say, the interface, think how I would lay out the components, and think about the structure you can give to your sizers in order to achieve the layout you designed, right? Another thing that I didn't show in my code, but is very important, is to add a tooltip to all the parameters. There is this tooltip property, which is a string, basically a text, and it pops up and it contains information. If you've noticed, all the processes in PixInsight has a lot of text regarding any control, because that's the only kind of documentation you can have, or at the moment you have for many processes. Create script instances is very, very convenient to have this dragging button to create instances on the workspace. This is how processes behave, and we expect scripts to behave like that. So don't ignore it where it makes sense, of course. Make your script installable, because as long as the script is kind of ready to be shared, PixInsight, this is the blood of PixInsight, right? So PixInsight would not be like it is today without the contribution of the open source community. So share your scripts and make them installable and prepare to be really onboarded as official PixInsight scripts. And the trick, don't forget to test your script as the first to be launched when you run PixInsight. And of course, share your work. I mean, we are all willing to see people proposing new things, new ideas, building their own scripts, and share it. This increases the community knowledge in general and improves not only PixInsight itself, but the community in general, the community of developers, the community of astrophotographers. I think it's very, very worth share what you're doing, disregarding if it's the super #1 script in the world or the super simple stuff. Yeah, thank you very much, and happy scripting to all of you. Okay, if you have some questions, I'm free to answer.
Yes, I have questions.
Sure, go ahead.
The first one is if it's possible to use CUDA with JavaScript.
The point is that CUDA will be, let's say, hidden inside the core of the function of PixInsight. So in general, it be hidden inside the JavaScript objects that you are going to use at the script level. This means that in any case, if you have a GPU on your computer which is suitable for our implementation, automatically PixInsight will use it. Under the hood, you don't have to programmatically say do this on the GPU.
The second question is that what if I would like to run the script, for instance, the one that we created together now with an image container?
This means that you want to drag the script on an image container.
I want
or
to,
vice versa.
Vice versa. I want to get the triangle from the image container over the script and executing for every image in the image container.
Yes, I think, but I will ask Eduardo to confirm that when you drag an image container on a process, there is an automatic batch processing that applies the process one by one to the image, takes the output and save it, changing the output name of the file. This means that it is valid for any kind of instance that is in the workspace that is just able to modify an image. I think so, right? Makes sense?
I think so.
Okay, but would it be in which context?
Sorry?
In which context would that?
That's a good question. My expectation is that it should be a target view context. Otherwise, it couldn't work. So, I mean, the point is that the image container should say, apply the script on this target image one by one.
Okay.
Yeah, so I mean, but just try it. This is my guess because that's the only way it could make sense. But just try it, and could be a good example to do a script and try it.
Okay. Thank
you. Obviously must be designed to work in target view. If it cannot work in target view, you cannot use in such a way, I suppose.
Yeah.
Is the script that must be ready for target view.
Yeah, what I wanted to understand is that the way when you drag the triangle of the image container over a script, if this is handled by the script itself or at the lower level in PixInsight, so you don't need to take care of it.
No, the point is that there is, of course, an under the hood management that detects that at the interface level, you're dragging an icon over an image. But this thing will trigger the execution of the script. And the script will receive some values on the parameters .isTargetView variable, which will be set to true by before the execution of the script, right? So the only thing that the script has to manage is to understand if this variable is true, and if there is a target view image assigned, then it has to perform the transformation silently and exit.
Okay.
Any other question?
Yes, I have a question. If we call a process from the menu, it's started with normally very reasonable default values as for all the settings, or most of the settings. If this process is available as external scriptable object, and I instantiate such an object inside the code, is then the object also using exactly the same default values, or will I have to set these values manually for all the arguments, for all the parameters that are available?
Yes, thanks for the question. That's a good question, because the answer is that when we instantiate a process from the scripting code, the instance will be loaded with the default values always. Right, so there's no reason for the process for a new instance generated programmatically to have different values than the default one, right? So the good news is that if you need to tune just a few parameters amongst the whole parameters, you just need to override them, right?
Yeah, great. That's what I was looking for. Yeah. Thank you.
So, okay, let's say good night or good afternoon to someone.
Exactly.
Okay, thank you very much. It was very
also my side.
A little bit longer than expected, but very, very interesting. So let's code.
Cool. We expect tons of new script in the next months.
Yeah, thank you very much. Great session.
Thank you. Thank you, guys.
Thank you very much.
Thanks a lot.
Really interesting.
Bye.
Good night. Ciao, buonanotte.